What's up, team? Today we're talking translations, reflections, and rotations. You see the learning target there. I can perform translations, reflections, and rotations on figures in the Cartesian plane. So just a heads up as we dive into this. This is going to be a general overview of all these things. We're going to define the terms as you can see, and then I'm going to do some examples for you in Desmos just to show you what we're looking for. Okay, so a translation, that's a rigid motion where every point is moved the same distance and in the same direction. So if you have some figure, like my eraser here, it's like you're just moving it. You can move it up, down, left, right, whatever the case may be, or some combination of those. You're just moving it. Every point's moving the exact same distance in the exact same direction. So it doesn't spin or anything like that. It's just moved, faces the same direction. A reflection, that's a rigid motion where the figure is flipped over a line of rotation. So say, again, my eraser right here, say there's a line of reflection right down the middle. If I were to flip this around the line of reflection, it just turns around. It's the same shape. It didn't really go anywhere, but now I'm looking at the back side versus looking at the front side. For a shape such as this, you might not even be able to tell that it was reflected unless you've marked your four vertices. But for some shapes that are not necessarily symmetric like this, it'll be very clear to tell, and you'll see that in my example here shortly. Line of symmetry. So that's like if I have a rectangle like this, this rectangle actually has a bunch of lines of symmetry. The first one is right here down the middle because it's the same on the left side as it is on the right side. The second one, it goes horizontally right across it because it's the same on top as it is on the bottom. If it was a square, you could argue the diagonals are also lines of symmetry. For the rectangle, that's not necessarily the case. And lastly, a rotation is a rigid motion that spins around a particular point. We think of rotation as just spinning, right? Like a propeller, right? And that's fair. That's like if the point of rotation was right smack in the middle, it would just spin around that point. A lot of times we'll spin around a point that's not inside the figure or it's the origin or something like that. So that might mean, the figure is here, but the point we're rotating around is here. So it would like spin around like this or the other way. So it's like there's a string attached to one end of this thing and whatever point we're rotating around, and it stays the same distance as it spins around there. Okay, now we're going to do a little bit of work in Desmos. Here I made a perfect star. It looks very perfect, nothing wrong with it at all, not weird. It's orange, and the top of it here, I changed that color of that point to blue. The reason I did that is so we can see if this spins at all, we can see where the top of it went. Okay, let's learn how to use this thing. I'm going to click this tab that says transform. I'm going to look down here, and I'm going to find one that says translation. So this one says I need 2 points, a from point and a to point. Well, I don't have a to point yet, so I'm going to just make up a point for the purpose of this example. I'm going to put it right here. That's where that point is now. I just picked that at random. Okay, now I'm going to go back. Translation, it says 2 points here. So I'm going to pick any points on my figure here. And let's say I'll pick this far end here. And then it says choose the point to, like where is this thing going? So I'm going to go to my random point now. Now it says select some objects to apply the transformation. Whatever object I select is going to make it, go to the right and then up to that point. So if I click on the figure that I was working with and I click apply, it's going to move this thing up and to the right. And every point is moving in the same direction, the same exact distance. Here you'll see here's the pre-image currently selected, and there's the image. You can see it moved exactly how we thought it would. The reason that the right arm is touching this random point is because that's the point that I selected. If I were to use this again, here I can make a different point. How about one right down here? And I use the translation tool. I can pick any other point. How about this time I'll pick the very top point, and I'll go to this new point that I selected. I'm now going to click on my figure, and I'm going to use translation to this time. And what this is going to do, it's going to take the pre-image, it's going to move it down here. So the top, this blue point, is going to be touching the top of this point when we click it, and boom, there it is. So this is an example of a translation. Of course, we can move up, down, left, right. There are no limits to where we can move this thing, but it's not going to spin when we do this. The top is always going to be at the top. Okay, let's look at a reflection. So what I have here is I have my same star, and then I put a line in. I just used this line tool here. I clicked on 2 points, and it inserted the line. So transform, define the transformation. This time we're doing reflection, and it says line here in parentheses. That's why I put a line in. And it says choose the line of reflection. So here we go, clicking on my line. And then select some objects to apply the transformation. We only have the one object, the very perfect star. So if I click apply here, what's going to happen is it's going to spin around this point here. So this the top is going to stay at the top, but this the arm that's currently on the left is going to go all the way around. It's going to be on the right. This one is only going to move a little bit, and so on. Let's see. Boom. There we go. You can see how it reflects around that line. Now, if I wanted to do something a little bit more creative, I could do, some line that maybe went through the figure like this. Maybe that, that line has some value or something. I could create another reflection. This time I'll choose my diagonal line and then choose my figure, apply reflection number 2, and this is going to be kind of weird. So it's going to reflect around this line. So here the top is not going to be pointed at the top any longer. We will see that it spun and the top point is down here because it spun around this thing kind of in a funny way. Here's one more reflection for you. This time I did something different. I put in a line right on the line of symmetry of the star. And here's what it means. It means that the left side and the right side are identical to one another. They're exact reflections of one another. So if I reflect this around the line of symmetry, check out what happens. So I'm going to go reflection. I'm going to click on the line. That's our line of symmetry. Click on the object. And when I reflect this, well, what should happen is it'll reflect, but you're not going to notice any difference because it's actually going to be the exact same shape. So it's the equivalent of me holding this eraser and me just spinning it around like this. So for the purposes of my physical eraser, you can see the erase side and the plastic side. For the purposes of the star, we're not going to be able to tell that we're looking at the back, but when we press it, we can see it's kind of just doubled up. It gets a little bit darker. We can, do it again. It's going to get darker and darker. That's just the Desmos's way of saying that we're stacking them on top of each other. So we had the pre-image, which is the very first one, and then several different images that were created by the reflection here. Okay, the last one I want to talk about is rotation. So I placed a point down here, kind of at random, and we're going to utilize said point. So rotation, it says we need a point and a number. The point, that's why I put it here. And the number is how much we want to rotate this thing. So, oh, I missed it. So it's 90 degrees. That's the default. I didn't change it, so it's going to be 90 degrees. So now it says choose point. Oh, here's where I change it. Good, good. So it's 90 degrees. That is exactly where I want it. So now what we're going to do is we can click on our image and then click apply. And what this is going to do, it's going to rotate it 90 degrees counterclockwise. So as we're looking at it, it's going to move to the left, and it's going to move it 90 degrees around this point. So imagine that there's a line or like some string or something that is attached right here, and we're going to rotate this thing 90 degrees so the line is pulled taut, and the star is going to end up this way with the top point here, the one that's currently blue, it's going to be pointing to the left. Boom, there it is. Here's our top point. If we do it again, it's going to be pointing down. Unfortunately, we're not going to be able to see the whole thing, but check it out. There it is. And if we press it one more time, it's going to go another 90 degrees pointing to the right. And then if we press it again, it's going to go back to where we began. Boom. Let's do one more rotation. This time I placed a point right smack in the middle of the star, or at least I tried to. I'm sure it's not perfect. But if we go to rotation, we click our points. This time, let's do a different angle. I'm just going to make it up. It doesn't really matter. How about 25 degrees? So now we're going to rotate 25 degrees to the left or counterclockwise. So I'll click the object, and if I apply this, it's going to spin it 25 degrees to the left. Boom. And if I press it again, it's going to go again, and again, and again, and we can just stack this on top of each other. We can get some pretty cool figures. Of course, the stars that you create might be a little bit better than mine. Mine looks kind of goofy, but you see what's going on here. Another fun thing that you can do within the context of Desmos, because it's a computer and it's magic, you can grab that point that we're reflecting around and watch what happens when I move it. It's going to redo all of those other reflections. And so it's treating all those reflections as if they happened right where this point currently is. It's kind of abstract, kind of trippy. But it's a lot of fun. You can do some really cool things with Desmos, creating art projects and whatnot. In fact, your assignment this week, you are going to be creating a piece of art using these three ideas within Desmos, these three transformations. Okay, have some fun with this. Let me know if you have any questions, and I believe in you. You got this.